morning to all. Today we are gonna see two DO of planar arm. This is a robot. It has two links which are rotational, and the end effector is a pen which is trying to draw a triangle. Now let's see how this actually works. We are using inverse kinematics to calculate the angles and the position of this. The main components that we need here to calculate the inverse kinematics are the length of the joints. It is necessary to calculate the length of the joints from where the links are there. It is we should calculate the distance from this rotational joint to the next rotational joint. Only that way we can precisely calculate the position. Now for this robot, the length of the link is 6.5 centimeter. Using the inverse kinematic equation, that is x is equal to L1 cos theta 1 and L2 is equal to cos theta plus L2 cos theta 1 plus theta 2. The same would be for the y axis as well. We have drawn a triangle. Since we are using an Arduino, both the servos cannot be actuated at the same time. So one servo is actuated after the other. So we get a crisscross pattern. But if you look closely, this is the first point and this is the second point and this is the third point. If we connect these 3 points, we get a triangle. Now I will show you how the code works.
Okay, well.
This is the code. As you can see, first we are using servo motor, so we have included that in the header file. Then we have using two servos, so we have declared them as servo 1 and servo 2. We have connected to the points 9 and in the Arduino we have connected them to the pin 9 and 10, and this is the function. First let's see the void setup and then we will move on to the function. In the setup, we are declaring both the servo pins, and in while loop, we are giving them the angles to draw the triangle. And since the links here are made of thermocol, they are not strong. So we need to move the servos very slowly. So for 3 of them, you lose the loop. And each time we are giving in the loop, for each position we are giving the input to actuate the servo 1 and servo 2. Here we are calling the function called smooth move. So if we move on to that function, we can see that the step size is 2 and the delay time is 50 seconds. First we are reading the current angle of the servo. Then if the current angle is less than the target angle, we are going to write the next position. And if the target angle is greater than the current angle, we are going to minus it so it reaches the target angle. This is the code that we have used to do this project, and this is the circuit connection. We have connected 5 volt and ground pin to the breadboard, and from that we have given the supply to the 2 servos, and the 2 servos data pin are connected to the pins 9 and 10. That's all. Thank you for your time. Bye.